Presenting my research on the neural correlates of dissociative states associated with trauma among former foster youth. This presentation is being done under the direction of Dr. Lindamarie Olson in the School of Social Work. So first, I would like to go into why we are using foster youth as our population for this study. Research has shown that children who have been in foster care have experienced childhood trauma at a rate that is higher than most other populations, at around 70%. 70% of children in foster care have experienced either neglect or abuse, or sometimes both. And this can have lifelong impacts on mental and behavioral health. Some of the reasons that children might be removed from their homes to be placed in foster care are abuse, neglect, separation of siblings can be common, and often there's very little warning. So the children are just taken from their homes one day because CPS does not want to alert the parents. And this can cause many symptoms, including impaired mental function, PTSD, and dissociation, which is a protective mechanism in which the child retreats into their brain in order to avoid whatever pain might be occurring. And that is the main focus of this study. So the goals of this study are to identify the rates of mental health and trauma symptoms among former foster youth using script-driven imagery and functional MRI technology. And using this data, we will develop and implement programming for former foster youth in order to increase retention in post-secondary education. So our overall protocol, first we will screen for eligibility. Our participants must have a formal diagnosis of depression or PTSD or some other condition that is born of their trauma. And then while they are in the MRI scanner, we will perform a localizer exam in order to locate their exact brain. And then we will do structural imaging for about 8 minutes, and then the functional imaging with the script-driven imagery paradigm for 30 minutes, and then finally a diffusion tensor scan. So what exactly is script-driven imagery? Script-driven imagery is a protocol in which participants select 3 memories based on certain conditions, and then they dictate their own script of what is happening in that memory for us to replay to them while they are in the scanner. This is an attempt to induce trauma symptoms that we can read the effects of in the scanner. So first, we ask them to dictate a neutral condition. This is a memory where there is no emotional attachment. This can be something like brushing your teeth or doing your laundry, something you remember doing and actively going through, but there's no emotional connection. And then we will simulate the trauma condition. This can be witnessing or even experiencing abuse or neglect or some other traumatic condition. And then finally, we want to end on a happy note, and this can be something like going to a birthday party or taking a friend out to ice cream. We start each scan with a baseline just to get their baseline brain levels. And then we play the audio for about 30 seconds, and we ask the participants to recall that audio actively for another 30 seconds. And then we give them 2 minutes of recovery. This run is completed 3 times for each condition for a total of about 27 minutes in the functional scanner. So how exactly does an MRI work? What does it do? MRI stands for magnetic resonance imaging, and it is done based on the hydrogen density in your tissues. So if you start out with some protons, we're assuming they are in the brain, they each have their own unique spin and axis. What the MRI does is induce powerful magnetic waves to force these hydrogens into a straight alignment. And then, once the magnetic waves stop, the protons return to their original position, and they give off energy as they do so. And it is this energy that the machine reads. The best scans are done when patients are fully hydrated so that we can maximize the hydrogen content in the brain. So there are 3 types that we are using. We are using a structural scan, a functional scan, and a diffusion tensor scan. A structural MRI is a complete anatomical picture of the brain tissues. This does not require an activity to be done, as it's done with static pictures. Depending on the type of scan, either fats or liquids, which are both very hydrogen dense, will show up brightest in the image. And this is based on, again, the hydrogen density differences in tissues. And then the functional MRI, this is the classic MRI that everyone thinks of, where you perform an activity and whichever areas of your brain that are working the hardest will show up the brightest. This is based on changing relative hydrogen densities in your tissues based on the blood oxygenation levels of your blood in the brain. So as you can see in this example image, this is an MRI of someone tapping their fingers together. As you can see, the areas of the brain that are lit up correlate most closely to the motor cortex of the brain, which is required for you to move your muscles. And then finally, we have a diffusion tensor scan. This measures the different connections in between the parts of the brain using the water that is flowing down the axons of your neurons. This scan, depending on the brightness and the color, tells you how strong and where that water is flowing, most brain activity. And the areas that are lit up correlate with the amygdala, which is the emotional center of the brain, the hippocampus, which is your memory center, and the prefrontal cortex, which is involved in higher order thinking and threat processing. This is what we kind of expected in this study, given that when you're in a traumatic situation, you are hypervigilant about everything around you, and you don't really have the ability to regulate your emotions correctly. And then in the bottom scan, the diffusion tensor scan, if you go back to the previous slide and compare, there is much less color in our participant scan. This means that their connections are weaker in their neurons, or they're even absent. And this strongly suggests abnormal connectivity in the brain compared to the standard scan. So our next steps with this project, we are still continuing to analyze behavioral and MRI data. One of the graduate students in the study put a small piece of our data on her computer for analysis, and it sent her computer into a comatose state for about 3 weeks. So it takes a very long time to analyze because they are so data dense. So we are still continuing working on that. We are also working on an R21 grant for pilot studies through the National Institute of Health in order to expand this study and change our protocols just a little bit. We are working on adding guided meditation after the active recall section of the functional scan, because we want to standardize the consistency of our scans. And we want to make it so that if a participant is recovering, we want to make sure they are actually recovering and not just recalling the memory that they just went through. We are also working on disseminating our research. We recently presented this at the World Congress of Psychiatry in Prague in the Czech Republic. And we are working on abstracts for the 2026 conference. And then finally, we are transitioning to new research. I am starting to work on a pilot project for which I will be writing a mini grant through the Foundation of Neurofeedback and Neuromodulation Research. Thank you for listening to this presentation. Are there any questions?
So I had an MRI once, and I had to, sit very still for a long time, and I can see how some people might experience some anxiety from that. How do you? Is it a potential that the actual MRI itself, when you're doing the non-traumatic memory or scripts, that the MRI itself might do a false positive of something when you're doing the non-traumatic ones? Is there any way that you mitigate that?
That is an issue, and we have played around with changing the order a little bit so that the happy may come before the trauma, so that we can make sure that the trauma is not still affecting the happy memory. As of right now, we are keeping the protocols as they are, but I do know we have discussed that.
Could you return to slide 5?
Yes.
Okay, so I'm just curious sort of about this. So you've taken this set of participants who have like a diagnosed mental health condition like PTSD. So I want to know, if these people, suffer from these conditions, how did this affect your, your participant pool? How many people actually would sign up to relive traumatic symptoms? And if so, how did you compensate them?
So yes, this study is being done with 3 people. It is a pilot study, so it's very small, and we are working on that grant to expand the study to get more participants. You're right in saying it's not the most popular study, knowing that people would not willingly sign up to relive their traumatic memories. But we do have these 3 participants, and it's still quite a lot of data that we can get from these participants. We've incentivized them through the use of gift cards. I believe it's a $50 gift card, maybe to Amazon. But yes, we're going through the University of Alabama channels as well.
What kinds of questions are you asking the participants on the responses to scripts, the driven imagery scale?
Yes, so the responses to script-driven imagery scale is a completely self-reported scale. It has to do with whether the participants are experiencing avoidance symptoms, dissociative symptoms, or even just reliving their memory, like being locked inside of that memory. And it's completely self-reported, so it can change from participant to participant, but that is data that we welcome because it is subjective, and we will analyze that as well as part of our behavioral measures.